equivalent equations, that's going to be the topic of our video today. Our learning goals for today. So the first one is that you'll be able to understand the term equivalent equations, and the second is that you'll be able to solve equations algebraically. Okay, so we say two equations are equivalent if you can get from one to the other by adding a number to both sides, subtracting a number from both sides, multiplying both sides by a number other than 0, or dividing both sides by a number other than 0. So what does that actually, well, what does that mean? So for instance, if we had 4x equals 20, an equivalent equation would be if we added, say, 5 to both sides. So 4x plus 5 equals 20 plus 5. So those equations are still equivalent. Or we could multiply both sides. So we could have, 3 times 4x plus 5 is the same as 3 times 20 plus 5, and so on. So you can see that they're equivalent equations because you're doing the same thing to both sides. So they're still going to be true. The equations are still going to have the left-hand side equaling the right-hand side as long as you're doing the same thing to both sides. Okay, so we use this to actually solve algebraic expressions. So what we have to do is we have to repeatedly find equivalent equations that are simpler and simpler until we're left with just the unknown. So for instance, 5x plus 2 equals 32. We can use equivalent equations to work our way down, getting simpler and simpler equations till we find out exactly what x equals. And the way we do this is to use the onion method. Now, remember, ogres have layers and onions have layers, and we are going to use our layers in our algebra. So we're going to circle in the middle of our onion what we want to find. So we want to find x. We want to know what x is equal to. And then we're going to build up the layers around x, like our layers in the onion. So the thing that's happened to x next, the next closest thing, is it's been multiplied by 5. So the 5 is our next layer of our onion. And then our outer layer is that plus 2. Now, to get to the center of an onion, you have to peel back all those layers. So the first layer is the plus 2. So we have to get rid of plus 2. So to get rid of something, to get rid of it, to get rid of it, we have to do the opposite. So rather than adding 2, the opposite of adding 2 is taking 2. So that will get rid of it. So on our left-hand side, we had 5x plus 2, and we're going to get rid of that by doing take 2. Now, to maintain equivalent equations, we also have to take 2 on the other side. So that will leave us with 5x equaling 30. Now, looking back at our onion, we've removed one layer, but we've still got another layer left, which is that 5. So that 5 and the x are joined together by multiplication. And the opposite of multiplication would be division. So what we're going to do is we're actually going to divide both sides by 5. And 5x divided by 5 is just going to leave us with x, and 30 divided by 5 is going to leave us with 6. So we know our answer there will be x equals 6. So you can see we've used equivalent expressions, equivalent equations I should say, to work our way down to find out our value of x. So we've got quite a few more here that we're going to play with to show you how it works. So we've got 5 plus 9h equals 32. So our h is our unknown. What's happened to h? Well, it's been multiplied by 9 and then the 5 has been added. So we're going to work our way through this onion to get to the center, which is that h. So the first thing we're going to do is get rid of that plus 5. And to do that, what we have to do is take 5. And we're going to do that from both sides to make sure we're maintaining equivalent equations. So that will leave us with 9h, and 32 take 5 is going to give us 27. Now the next thing we've got is that 9, and it's joined to the h by multiplication. So to get rid of it, we're going to divide by 9. And we have to do that to both sides to make sure we have equivalent equations. So 9h divided by 9 is just going to give us h. 27 divided by 9 is going to give us 3. h equals 3. So we've used those equivalent equations, we've used our onion method, we've worked our way down to find out our value of our unknown. So h equals 3 is our unknown. Clear the screen and we'll do B. So we've got 22 take 4D equals 8. So D, it's been multiplied by -4, and then we've had 20 added. So to make our way through that onion, we're going to work backwards. So the first thing we have to do is get rid of that 20. Now, students often get confused at this step, saying, well, how come we don't add 20? Like, why are we doing take 20? Well, the reason we're taking 20 is this is a positive 20. There's no negative in front. If it was negative 20, we'd have to add 20, but it's positive 20, so we have to do the opposite, which is take 20. So that will leave us with negative 4D equals 8 take 20, which is going to give us negative 12. Now, to get rid of that negative 4, we're going to have to divide by negative 4. And what we do to one side, we have to do to the other side. So negative 4D divided by negative 4 is just going to give us D, and negative 12 divided by negative 4 is going to give us 3, because remember, negative divided by a negative is a positive. So our answer is D equals 3. Now, if you're ever in doubt, you can always substitute it back in to check that you were correct. So if you're not sure, if you don't really believe me about the 20, let's substitute it back in to see if I was right. So 20 take 4 times 3 equals 8. So using our order of operations, so 20 take 4 times 3 is going to leave us with 12 equals 8. 20 take 12 is 8. 8 equals 8. Yes, we were correct. So remember, you can always substitute your variable back into your original equation to check that it's correct if you're not sure. And if your answer isn't correct, go back, see what you've done wrong. Okay, we'll clear this one again. So now we've got 34 equals 4 take 5J. We want to find out J. What's happened to it? Well, it's been multiplied by negative 5, and then we've had 4 added. So what do we do first? We have to get rid of that positive 4 by taking 4. So remember, we're taking 4 because this 4 is positive. If it had negative 4 at the front, then we'd add 4, but it doesn't have negative 4. It's a positive 4, so we have to do the opposite, which is take 4. So that will leave us with 30 equals negative 5J. Now to get rid of that, we're going to have to divide both sides by negative 5. So 30 divided by negative 5. So positive divided by a negative is going to give us a negative. So negative 6 equals J. If you're not sure, substitute it back in. Check. So let's check whether we were correct. So 34 equals 4 take 5 times J, and J we think is going to equal negative 6. So 34 equals 4 take 5 times negative 6 is going to give us negative 30. And remember, when we're taking a negative, it's the same as adding. So 34 equals 4 plus 30. 34 equals 34. Good, we were correct. So make sure you're always substituting it back in so that you can check whether you're correct or not. Clear our screen for our lucky last one. We've got negative, oh, what happened to my pen? Negative 22 equals 14 take 9B. So we're trying to find B. What happened to B? It was multiplied by negative 9, and then it had 14 added. So first thing we're going to do, take that 14 away. Again, we're taking 14 because it's positive 14. There's no negative sign, it must be a positive, sorry. So negative 22, take negative 14. We're going to get more negative, so it's going to give us negative 36 equals negative 9B. Now we have to get rid of that negative 9B, so we're going to divide by negative 9. Divide by negative 9. And negative divided by a negative is going to give us a positive. So negative 36 divided by negative 9 is going to give us a positive number. And that's going to be positive 4 equals B. And again, we're going to substitute that back in. We're going to check our answer to see if we are correct. So negative 22 equals 14 times negative 9. Oh, sorry, that should be take, not times. Where's my eraser? Just erase this. There we go. So 14 take. Start again. Rub all this out. 14 take 9 times 4. So negative 22 equals 14. Take 9 times 4 is 36. Negative 22 equals 14. Take 36 is going to give us a negative number, and that will be negative 22. Yes, so we were correct. Good. So that's the way we solve equations for our unknown. We use our equivalent equations, we use our onion method, we're just going to do the opposite, working our way back. And don't forget the last important step, which is checking your work. So if you always check your work by substituting your answer back in, you'll be able to find out straight away if you're right or wrong. So that's really helpful in a test situation. You can check your answer straight away, identify straight away if you need to go back over a question. So that's all we have for today's lesson. Make sure that you've copied down these examples, and as usual, if you need help, come and see me in class.